This lesson is about how to write and interpret numerical expressions and compare them with a visual model. Before we go too far, there are a couple terms that you need to know. It's important that you know what each math term is related to. The sum is the final result of addition, product goes with multiplication, difference tells you subtraction, and quotient tells you division. If you don't remember these, please study them. You will need to know them. Okay. We need to remember that when we have math problems, that the solution is called different things. For an addition problem, we call it the sum. For multiplication, it's the product. When we talk about difference, that is for subtraction. And the quotient tells us division. You're going to need to know this as we go through different problems and putting them into a word form. You might also see something that says the value of the expression. That is simply talking about the end result of solving an equation or an expression. If we have an equation 2 plus 3, the value of the expression would be 5. Next, you need to remember the order of operations. Most of you, if not all of you, learned about PEMDAS last year. Okay? You also need to be familiar with the order of operations. Many of you learned this as PEMDAS. Please excuse my dear Aunt Sally. Okay? This lesson, that is extremely important. You need to know this. Okay? Standing for please excuse my dear Aunt Sally. PEMDAS stands for parentheses. That's what you do first. Okay? Then you go to the exponents. Then you multiply, divide, add, and subtract. It's not that we like any of these less or more than the others. It's just we need to take care of them in this order. Okay? Now let's look at a couple of the problems. And representing it for parentheses, exponents, multiplication, division, addition, and subtraction. What's becoming more common now is GEMS, where the G stands for groupings, where it can be the parentheses, it can be brackets. There are multiple different groupings that you can use. Exponent stays the same. Multiplex, which is talking about multiplication and division, and simplex with addition and subtraction. Be familiar and able to work with both, but use whichever one is easier for you. Using that understanding, we're able to take words and turn them into equations. Take 3 times the sum of 26 and 4 as an example. In this example, there are different meanings associated with it. 3 still means 3. Times is telling us that we need to multiply. Okay? But when it says the sum of, that's telling us we need to do something first. So we're going to use our parentheses, okay? Bring down our 26, and it is the sum. Sum is telling us addition. So we're doing 26 plus 4, because our 4 comes down, and we need to remember to close the brackets. We cannot leave those open. So 3 times the sum of 26 and 4 tells us that we are multiplying 3 by this addition problem here. We can represent that visually with a tape diagram. With this tape diagram, we're starting with a large rectangle, and we have it split into 3 sections. The 3 sections represent the 3 times, and inside each section we're going to have 26 plus 4. As we solve that, we see that each section of 26 plus 4 is the same as 30, so we can do 30 plus 30 plus 30, which we know is 90. The important idea here that we want to get across is not solving the problem so much as turning the words into an equation. Try this one on your own. 6 times the difference between 60 and 51. Think about how you're translating it into the equation or the expression and where the parentheses need to go first. The first thing I did is I turned it into an expression. 6 times comes straight down. Difference tells me I'm doing a subtraction problem, and it's the difference between 60 and 51. Okay, these get grouped together in the parentheses and they're right next to each other. Then I'm going to draw my tape diagram. When I did my tape diagram, I have 6 sections inside the tape diagram, and I did 60 minus 51 in my head instead of writing out the equation. And 60 minus 51 is 9, and then I have 9 6 times, so it's 6 times 9, which I know to be 54. What about when we have an expression and need to convert it into words? Here we have a number that a lot of people would describe as 16 plus 9 times 4. The problem with that is it sounds like 16 plus 9 times 4, which would give you a different product, which is not what we want. So how can we write this out? Well, we need to make sure that we have our correct verbiage. So we have plus being the sum. So what I would do is I would do the sum of 16 and 9 to represent the first section. However, if I say the sum of 16 and 9 times 4, then I come back to this expression that is incorrect. So the way that I would simplify that would be to say, put the times 4 first. So I would write it as 4 times the sum of 16 and 9. That way it helps you know the correct order of operations. And remember that I'm able to move that around within here because of the commutative property that we talked about the other day. We also want to be careful to make sure that we are using the word sum or the word difference, not saying this plus this or this minus this. Okay? It needs to be a little bit more clear and concise. Try this one on your own. Two possible solutions are the sum of 23s and 5 3s, or you could say the product of 20 and 3 plus the product of 5 and 3. Realize that, yes, I am saying plus here, but it is to link this first product and this second product. You want to be careful not to say 20 times 3 plus 5 times 3 because it is not clear what you're trying to say. Now, if you're asked to compare equations or compare expressions, that just means solve the expression or solve the equation and compare the final solution.